Hey, good evening, AP Physics students. Going to talk about Pascal's principle today as we look at chapter 10, number 12. Okay, Pascal's principle states if an external pressure is applied to a confined fluid, the pressure at every point within the fluid will increase by that amount. This is the hydraulics law. Have you ever seen your car get lifted up at a repair shop? They're using hydraulics. Hydraulics are also how brakes work. And here's how it works. So let's say I want to lift up a car, right? So here's my car, right? It's my good-looking car here, right? Car. I better label it, okay? Well, if I exert a force here on a piston over here and I have a small area and a small force, the pressure here gets transmitted all the way around the fluid here. And here, since I have a large area, I will get a large force out, all right? So I can create a lot of force with a little bit of force. This is a force multiplier. Now, it doesn't increase work because I'm sacrificing distance over here for force over here. But the pressure I apply in gets transferred out over here. So, in problem number 12, it gives us the following information. It says there's a hydraulic lift, and the fluid pressure gets exerted on the fluid, and the maximum pressure that can be exerted is 17 atmospheres. Okay, so if I have 17 atmospheres, what's the mass of the largest car that could be lifted? Okay, so the first thing I do is whenever I see the unit atmospheres, is I like to convert that to pascals. Okay, so we all know that 1 atmosphere is the equivalent of 101.3 kilopascals, or 101,300 pascals. So 17 atmospheres is a lot of pressure. That turns out to be 1,722,100 pascals. Well, we're also told that the area, we're given some information about the area. We're told that the diameter is 28 centimeters. So the area of this piston over here is going to be pi r squared, or in other words, 3.14 times 0.14 squared, which turns out to be 0.06154 meters squared. Okay? Now, the force out, okay, the force out that will be produced, we know from our definition of pressure that force out, maximum force out over here, will be equal to the pressure times the area out, okay? Or 1,722,100 times 0.06154, and we would get, now this is newtons per meter squared times meter squared, so the resulting here force out will just be in newtons. I get, if I round to 3 significant figures, I get 106,000 newtons here, all right? And we're not quite done here because this problem wants us to calculate not the force out here, but what is the maximum mass of a car that could be lifted here. So the force out would be equal to the weight of the car, which we all know by now is mg. Therefore, m would be the force out divided by g, or 106,000 newtons divided by 9.8 meters per second squared. And we would get a mass of 10,800 kilograms, okay? Or over a 20,000 pound car, over a 10-ton car could be lifted. So, Pascal's principle here at work in hydraulics, all right? All right, Nice work, physics students. I got a joke for you today. Hey, Mr. Kirsten, what's the best concert you've ever been to? Well, the best concert I've ever been to actually only cost 45 cents. Only 45 cents? What concert was it? Well, it was 50 Cent featuring Nickelback. Get it? Now, for the visual learners there in the audience here, let me just explain that joke. Yeah, I've got a quarter here and 25 cents, so if it's 50 cents minus nickel, see, it only costs for, oh, that's not a quarter, that's a, well, oh, shoot, I screwed that up. All right, nice work, AP Physics students. We'll see you tomorrow.